Join discord.gg/flat earth and enter a VC check-in room, and someone will come along to VC verify you to get involved with the conversation about our Earth.
Enemy spotted.
Kosho Part 2.
I got a question. Is Godric here?
Oh. Yeah, I'm here. What's up, Kosho?
I made you that picture, bro. I made it for you because fond of you, and the thing you said about the inner Earth and the gravity and everything. Do you see the picture I made?
You drew a picture for me?
Yeah. And do you see it though?
Yeah. Push you down, push you out. Yeah. So
Yeah, the first one is you being on the surface, and you'd have all the vectors pointed all over. There'd be more vectors than that. But the point is, you understand that the vectors that are equal and opposite, they cancel each other out. So if they're pointed in two different directions at the same angle, I guess you'd say, they more or less cancel each other out. So if you add them all together, you get one vector. That's how vector math works. You add all the vectors together, and you end up with one vector, and it's basically the vector that's going straight down, which is why gravity's, acting straight down. And the only difference between that and being below the surface, in the second picture, is that there's more vectors, but all the vectors cancel out again, except for the one acting directly up and the one acting directly down. They'll cancel each other out, but they're not equal. So you'll just end up with a less downward, force, less weight. And as you get to the center, all the vectors cancel each other out, and so you're effectively weightless. But there's no contradiction there. That's what you described it correctly, I thought, but your conclusion, I thought, was wrong, because there's no contradiction. It's
Right. So what you're saying is that when we're at the center of the circle of the piece of paper that you drew, then we'll have equivalent forces.
oh yeah, right, exactly. All the vectors that are acting as attractive forces to you, they'd be canceling each other out. That's right.
You didn't get it, brother. But maybe you did.
Oh yeah, we both get it. Yeah, that's what I thought. I thought you got it too. We both get it.
right. Yeah.
No, I said when I'm in the center of the picture that you drew.
Yeah.
Yeah, Kosho, this is good. But if you're in the center, right, and you have zero weight, correct?
Yeah, effectively, yes, because all the weight, all the vectors will be in all directions around you. They would all cancel each other out.
Okay. So first thing I want to say is this is going to debunk the claim that I think so. It may not. That when you fall to the center of the Earth, you'll be crushed by gravity.
You
That's
don't get
what.
crushed by gravity. No,
That's
you
what.
don't get crushed by
This is the
gravity.
claim.
Right. But you don't get crushed by gravity. Just like in the center, as you go under the water, you're not getting crushed by gravity. You get crushed by the pressure of the water. The weight of the water is acting downward on you, and it's gonna hurt. That's what you're getting
Yeah, but
crushed
hang
by.
on. But let's be fair. Let's be fair. The water being above you presses downward, right?
Yeah,
We don't want to assume that happens on a globe, right?
sure.
So back to this. Thank you for the drawing, by the way. Nice drawing. Um, back to having zero weight, right, in the center of the globe or center of the sphere. You claim that the vector is nullified because
Yes.
you're being pulled every direction equally, which means you have zero weight, right?
You have zero weight. That's right. Yes.
So here's the problem. In the center of this sphere, a rock or asteroid, a planet, whatever, there's no reason for it to stay together because there's nothing pulling it to the center.
Yeah.
There's nothing in the center pulling it. From the center, that mass that's in the center it has no forces that pull it together. And matter of fact, instead of pulling together, it pulls it outward.
Wait, no, it doesn't pull it outward. But you didn't have this. You didn't hear this from Brian Leakey, did you? Because I had this very long aggravating conversation with Brian
No, no,
Leakey.
I'm just, just like having a brain
Oh yeah, it's
fart.
fine. No, that's it's interesting.
I
It's
don't know,
interesting.
I don't know what I'm
It's
talking
interesting
about.
to me. No, no,
I
no. But
just
it's
thought
interesting to me.
about it in my mind, and I thought, how is gravity pulling you to the center if you're weightless in the center? That's what I was
Absolutely.
thinking.
No, no. Okay, that's fine. Actually, I'm curious about. Like I said, it's interesting that both of you have come to the same conclusion. It must be a. It must be like a regular train of thought type of thing. Um, and to be honest with you, I can see how you would get there because it's just counterintuitive that there's zero weight all acting on you, yet there's an enormous amount of pressure acting against you, and obviously against the mat, like the core of the Earth is there supposedly, so there's a massive amount of pressure. But you have to remember that uh, the gravity acting on you there is very small, to zero almost. It's not the same thing as the gravity acting on everything above you in all directions, right? Because it's not just the gravity acting on the rocks around you, but the rocks around that and around that and around that, and they're all acting towards you. So there's an immense amount of pressure, all acting towards you from all directions, regardless if there's no weight uh, acting on you. That makes sense.
Okay, so let's say I'm 200 pounds, and this Earth sphere is pulling me down, right? 200 pounds down because I'm on top of it. But you start going to the center of the sphere, and eventually that weight, it's the same amount of weight, by the way, is pulling me outwards, like stretch me like a Stretch Armstrong. Follow me?
No, no, no.
So
You're not being pulled. You're not being pulled.
hang on,
Go,
wouldn't
go,
the
go, go, go.
200 pounds that's pulling me down, wouldn't that be also stretching me out like a starfish,
No. If
pulling
you
me
were
all
on,
directions?
if we were in an extremely dense material, maybe like like they say you get spaghettification or something in a black hole or
But
neutron
but
star.
Kosho, but Kosho,
No,
but
but
Kosho,
but the vectors cancel each other out. When you add the vectors together, they're not working at the same
Kosho, they,
time
they,
on
they
you.
can't cancel each other out because you claim mass attracts mass. So it is pull every bit of that mass. If you're in the center of this sphere, let's say a rock, an earth, whatever, every bit of that mass is pulling you outwards because gravity is always working. Correct. In other words, my hand is being pulled, north. My other hand is being pulled south, kind of like you're stretched out like in a torture device when you got four horses pulling you in four directions. The shit they did, to mess with the people like war victims, whatever,
Yeah, but
captors or victims of war, whatever. You take four horses,
oh yeah, I understand. I
hang
understand.
on a second, and you have the four, and you hit that ass, and they go in four different directions, and you get your arms ripped and legs ripped off. So wouldn't that happen if you're in the center of a sphere and then that gravity is pulling you outwards?
Yes, I understand what you're saying. That's why I said in a black hole or a neutron star, you might experience something like that. But in regular Earth, right now, the gravity acting on your feet and the gravity acting on your head are so close to the same value that you do not experience. You don't feel it any different. You don't feel like you're being pulled more from your feet than you do from your head. So your whole body gets basically the same sensation, and it's going to be the same from everything. So the gravity acting in any direction on you from any point
But
of your body,
Kosho, but
the
Kosho, when I'm on the
gravity acting
outside of
in
the
any
sphere,
part of
I'm
your body.
200 pounds of weight being pulled down. When you're on the inside of the sphere, that exact same 200 pounds has got to be
No,
distributed all around you, pulling you back out by 200 pounds. Meaning, you'll feel a pull on your arms, your head, your legs. It
no,
would
it's
be a
not 200
pull.
pounds anymore. It's not 200 pounds anymore. Actually, the way that you calculate it, there's a simple shorthand. Is if you're below the surface, you then use the Earth. Uh, you basically pretend that the Earth is a sphere the size of the uh, radius that you're now at. So it's like let's say you go 1,000 miles below the surface. You now pretend the Earth is 3,000 miles in radius, and then it has that volume that big with that much mass, and then you calculate your gravitational attraction from that. Um, Yeah,
I
see,
don't
that's
see how you can say, Kosho, that if you're in the center of this sphere, which gave me 200 pounds of weight, that's not pulling me outwards by 200 pounds. I don't see how you can say that. I don't see how you can say that gravity nullifies. That doesn't make any sense to me.
because
You'd
that's not how
still be
vectors.
pulled. Still be pulled by that mass, unless mass doesn't attract, which I don't think it does, by the way. Then
Okay.
then you wouldn't feel any pull, and you'd be and you I get I agree that you'd be weightless. Fine, I'll go with that because it's pulling you equally, but it's pulling you, so
Hmm.
you feel that pull.
Imagine that you're in a you're playing air hockey, okay? And there's a puck on the table, and there's there's a wind that's there's a a wind that's pushing the air puck across the table, coming from one direction, and it's 10, that force of 10. Hold on one second.
I'm glad you use that. So let's instead of pushing, let's do sucking wind, right? Like a vacuum cleaner, right? It's sucking you from all directions. That's how you'd feel in the center of this earth. You'd be sucked outward. And if that's the case, right, nothing would ever gather in the center of everything, of anything, because there'd be no gravity in the center of things, and it's not sustainable. All the rocks and all the huge supposed planets would just bust apart because there's nothing to hold them together. That's what I see it. It's like oxymoron. You can in theory you can have mass attract mass, but with the moment it got together, it pull itself back apart. Actually, if planets form, if a planet ever formed, right, I would claim that the center of the planets would be hollow because, like you said, there's no weight, there's nothing pulling nothing in the center. So this mass eventually it would form like a hollow egg. That's what would happen with all spheres. They'd be hollow in the center. Just thinking out loud. Call me crazy.
Sorry, Patrick. I don't remember where we were at, but um,
Well, I was just thinking out loud, like, I don't think any planet would ever form, quote unquote, planet, because, like you talked about, there's no gravity in the center, right?
no, there's not that there's no
So
gravity.
all the,
That's what I
hang
was.
on, hang on,
Okay, yeah, that's
hang
what.
on, hang on, hang on,
Go ahead.
all
Go ahead.
the center, all these Jupiter and Venus and Uranus, they'd be like a hollow egg because all that stuff in the center would be pushed out to the surface where the mass
No, it
was.
would not. That's silly to think that.
Well, you told me
There's
there's
no
no
way.
weight in the center, so there's nothing
Yeah,
pulling you in the center.
that doesn't mean something's pushing you outwards.
But
Okay,
hang on,
listen.
if you're in the center of a mass, there's mass pulling you back to the surface because that's where the mass is. This is just logic.
No, it's not logic, Patrick. Just listen to me for a second. Just imagine
Hang on, hang on, hang on. Look, you take four vacuum cleaners, right? Turn them on.
no.
Hang on a
Forget about the
second. You
vacuum
put a
cleaners.
marble. Hang on.
Forget about the
Put a
vacuum
marble on a
cleaners,
plate.
Patrick.
Put a marble on a plate in the center, and then you take those
Just
bacteria. You start putting them close to that
use
marble. All those
use
bacteria are going
leaf
to be
blowers.
competing for
Use
that
leaf
one
blowers.
marble. This
Use
is your
leaf blowers.
gravity. This is your
No,
claim on the gravity.
no, it's not
Those
my claim,
bacteria
Patrick.
pull them close to that marble. Going to try to suck that marble in the four different directions.
Okay,
This is
stop
what happens
using
if you're in the center of
vacuum
a
cleaners.
plane. And if that's true, there is no way a sphere would ever form more than a hollow
Patrick,
eggshell.
just use leaf blowers.
Okay, I'm done.
Yeah, use leaf blowers. Don't use vacuum.
But Kosho, do you realize a leaf
Patrick,
blower
stop,
does the
stop,
opposite?
Godric, just
Wait,
stop.
Kosho, a leaf
I
blower
understand
is
what
the
you're saying,
opposite of
man.
what you claim. It pushes. You're
No, it's
saying
not.
gravity pulls.
Yeah, no,
You're
stop.
saying it pulls. Now you're saying a leaf blower pushes, Kosho. You got to get
Godric,
it right.
Godric, relax for a second. Just relax. But you're right. You have the right idea. But that's not usually that's not use vacuums because that's not correct. But a leaf blower, that is correct. Okay, and you're right to think that it's yes, it's gonna attract it, but it doesn't make sense to do this. So let's not use a vacuum cleaner. Let's use a leaf blower. Okay, and use something on a frictionless table or ice or air hockey table. Doesn't matter. Something that's frictionless. Okay, if you have a leaf blower with X amount of force in one direction, and you have another leaf blower with, you know, let's say that was 10x. So now you have a leaf blower with 5x in the opposite direction, pointing right at the same thing in the opposite side. Okay, what you're going to do is it's going to go towards the side it was headed, that the 10x was pushing it, but you're going to subtract the vector that's going the opposite direction. So you're going to end up going
That's not what would
5x.
happen, Kosho.
Yes, that's exactly what happens.
What would happen is you'd be hit by 5 pounds of force on one side and 10 pounds of force on the other side. You'd be hit
Yes,
by
I know.
15 pounds of
Cancel.
force,
No, you
and
know.
you would have a
Godric,
positive 5. You would be pushed to one side, but you'd be hit by both sides of force, Kosho.
Godric, you don't add
Does
those
not,
together.
does not,
How that
it
works.
does not cancel out.
Godric, the way that math works is that you would add the vector. There'd be a positive value. If there's one in the opposite direction, it would be negative in comparison. So it would go, if you're talking about a coordinate system, same as a coordinate, in the coordinate system, you would describe it going positive x. And if there's the opposite direction would be negative x. And so you subtract one from the other. And what you end up with is one vector going in one direction. Because the puck is
Kosho,
not
you're
going,
Kosho.
hold on, God, this is the most important part. The puck is not going to move in two directions. There's only going to be one vector of force acting on it. It's going to go in exactly one direction. Even if there's a bunch, like a million different fucking jets acting on it, it's only going to move in one direction, and it's going to go in that direction with some force. And that force is going to be equal to whatever the vectors acting on it, canceling each other out. Whatever's left over is going to be the direction it goes at that magnitude.
Kosho, you're half right. Okay. It will go, an example, if you get 10 pounds on one side, 5 pounds on the other side, you're going to get a positive 5 pounds and you're going to go to one side. But but you're skipping over completely. It's the fact that you're getting hit by 10 pounds of pressure on one side and 5 pounds of pressure on the other side. So, like when you stick your head out the window and you're going 60 miles an hour, all that air goes in your mouth and you look like a funny face because all that air is like blowing your mouth open. That's happening on both sides, Coach. It doesn't cancel out.
Yeah, but you're describing some weird scenario when we're we're talking about an effect that happens not in the way you're describing. Air is a dynamic you know wall of energy. It's not like a
So 10 pounds of air on one side, you're going to feel that 10 pounds of air, Coach. You're going to feel it on your back, for example. And if you hit yourself in the face with other 5 pounds, you'll feel 5 pounds in the front. It doesn't cancel out.
Or if you're doing bumper cars, and there's people all around you. There's two people hitting you from both
Wonderful.
sides.
You'll feel yourself getting hit by both sides, Coach.
Yeah, yeah, but if two people hit you at the same time, and everyone's craft is rigid, no one's craft is gonna crush. Then if two people hit you at the same time, whichever person has the more force, they're gonna subtract the other person's force off of yours. I mean, off of theirs, and it's gonna go in their direction because theirs was bigger. But it's gonna subtract from theirs. And it's gonna go in that direction. It's gonna seem like a single force acting on you.
Yeah, you'll probably get whiplash. If your head was between two of those bumper cars, you would be crushed, Coach. Both sides of your head would be injured, not just one side.
I just told you it was a simultaneous. It was simultaneous, and it was also a rigid craft.
If you put your head between two bumper cars and they hit you simultaneously, you get crushed, Coach.
These are rigid crafts. Nothing can get crushed because they're all rigid. Okay.
But Coach, let me help you out. You don't want to use leaf blowers or bumper cars. You want to pull. Gravity, according to the claim, pulls you outwards. Doesn't push you forward or backwards.
Okay.
It
Fine. How
literally
about this?
pulls you to the mat.
Okay.
The moment you go into the center of the sphere, it's pulling you back out to the surface, Coach. There's no way to think about it.
All right, Godric. Instead, let's say you have a ball, okay? A very heavy ball. Doesn't matter how heavy it is, but it's got fucking nails coming out of it, okay? And a million nails in all directions. You have ropes tied to each of those nails, okay? And there's varying amount of force pulling that ball in those directions. If you want to determine or predict where the ball's going to go, you would add all those vectors together, and wherever the greatest whatever is the greatest direction. So once you cancel out all the directions it's going, it's only going to go in one direction. The ball's going to move one direction. It depends on where the vectors add together at. So
I agree that you'd be floating in the center of this quote unquote sphere because there's no vector because it's equal mass. Hang on, it's equal mass around you. However, you'd feel the pull from this quote unquote mass, gravity pulling you outward. You'd feel the pull. It wouldn't be nullified. Just like you'd feel the pull being on top of the sphere. I'm 200 pounds. I feel the pull getting pulled down. You also feel a pull pulling you outward from the center, pulling you outward towards the surface again. Now, to be fair, it wouldn't be 200 pounds because um, you're getting half of the sphere is pulling you up and half is pulling down. The other, so let's say you're getting pulled all directions. So maybe it's like maybe it'd be 25 pounds of weight of a pull because it's going all directions. I'm dividing the mass that the tonnage and mass that gives you weight. Let's say 200 pounds. Break that up evenly in all directions. And that's how much you're going to get pulled in all directions. Kind of like when you, like I said, when you tie yourself to four horses, hit them on their ass. They go all different directions. I say just use vacuums because vacuums suck, right? So you'd be pulled evenly outward, even if it's only I'm not saying how much, but you'd be pulled evenly outward in
Godric,
all directions, being in the center of a sphere by the mass that's surrounding you, that's encasing you.
Godric, when you're on the surface, this is going to be the maximum amount of gravity that body's going to apply to you. So you'll be far away from the surface, you're below the surface, but if you're on the surface, it's a maximum amount of gravity. So when you're on the surface right now, standing on the surface, do you feel like your body's being ripped apart? Even though there's the top of your head and the bottom of your feet have two different distances, right? They're being pulled two different um, uh, in two different ways. Do you feel a difference? No, you don't.
No, because there's no gravity.
Regardless, Godric, if you were below the earth, it wouldn't matter that you're being pulled in different directions. You're not going to feel it on your body because it's not
That
that.
weight that you feel on your feet, or if you're sitting down, I'm sitting down right now, so I have to have a weight on my ass and some weight on my feet because they're flat on the ground, right?
No,
And some weight
that's
on
not.
my arms that I'm on. Oh, I'm
That's
bending.
not.
Hang on, I'm bending over this table, so there's some weight on my arms, right? So I have 200 pounds evenly distributed going downwards. Some
None,
on my feet, some on my
none,
ass, some on my table. That
none is weight,
exact
Godric.
weight is going to be distributed equally, being in the center of the sphere, pulling
No.
you back outward. Am I wrong?
0% of that, yes, you're 100% right. 0% of that is weight. That's called the normal force. If you notice it, is it acting downward on your ass or upward on your ass? Upward on your feet or downward on your feet? Or upward on your arms or downward on your arms? It's acting up.
Everything is downward.
No, those forces are acting upward, Godric. You don't feel it acting downward on your ass. It's acting upward
I
against your
said
ass,
downward because that
against
gives
your
you the
feet.
weight. 200 pounds, if I put on a scale, is 200 pounds. It gives me my weight, Kosho. So it's
Yeah, but that's
downward.
not what you feel. You don't feel that though. You feel the normal force acting against you.
So my response to that is because there actually isn't gravity pulling you down. That's why you don't feel it the way you say you feel. But you do feel your feet pushing on the ground. 200 pounds.
Godric, you don't
So
feel that. Do you feel your feet pushing on the ground or do you feel them pushing against your feet?
what the hell's the difference, Kosho? There's pressure on my feet.
One is acting on your foot and one's acting on the ground.
If I was in water, I would sink into the water because of that
Okay, but what do
pushing
you
down.
feel? You feel the pressure of the water acting on you. You don't feel yourself pushing down on the chair. You feel the chair pushing up against you. That's just what you feel.
That's just a relative thing, Kosho. It's like a word game.
It's not a word game. I mean,
You're putting
this
you're putting weight on the scale. It doesn't matter if it's pushing up or you're pushing down. It's the same
yeah,
thing.
this is the act that you're applying to the scale. But in the case of you being below the earth, the thing pushing against you is the earth. And it just so happens that it's not just the weight of your body acting against the earth, it's the pressure of the earth above, around you in all directions. It's going to be pushing against you. And it's going to crush you.
Kosho, the mass being under your feet, okay, gives you 200 pounds of weight on the surface. Submerging you into the center of the sphere, that this mass that you claim is pulling you down. So they pull you right back out to the surface of the sphere, Kosho. Is that not right?
It is right, but that gets canceled out. That's being canceled out by the opposite force.
There's no canceling. You have to add all forces. Just
Yep.
like bumper cars, just like you'd feel yourself sandwiched between two bumper cars. If one was stronger than the other, then you would have a vector. Same thing as if you had four vacuums and you moved it into this let's say marble in the center of a plate. The marble eventually gets sucked up by one of the vacuums, but you'd feel the suck on all the sides.
A marble's a marble's a much better point. Okay, because a marble is rigid, meaning when you suck it up with a vacuum, it doesn't rip apart because you're sucking it. It doesn't get sucked at one end and then not at the other end, and so it pulls apart. So if you have two vacuums pulling on a mag on a what do you say? Marble. I'm sorry. If you have two
You would
magnets
literally
pulling
be
on a
pulled.
or two, you have two vacuums pulling on a marble. It does not get pulled apart at all. It's rigid, and so what happens is the vectors will cancel each other out. You have to think of this body as a rigid body because anything with the Earth's acting on it, the Earth is not going to rip anything apart. The gravity is not strong enough to rip the human body apart.
I
You're
didn't
not
say
going to
rip
do it,
it apart. I said being pulled outward.
but you're not going to experience that. That's not. It's not. Okay.
I don't see how, Kosher.
I'll give you this. I'll give you this. Like if even if you have a zero uh, weight, I actually agree. You'll be pulled in all directions outward, but it will be inexperiencable. It's not going to be something that your body's going to
Well, hang
experience.
on, hang on. Do we agree that in the center of a sphere you would just float like you're levitating? Yes or no?
Yes, 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 yes.
Because there's no weight. Because there's no
Yes.
mass. The
Because you're
mass is
pulled.
on
No,
the
there's still the
outside of
mass.
you.
No, the mass is exist. Your mass is your mass. It's just that your mass is being pulled in all directions, and so there'll be like tidal. There'll be tidal effects because of that,
You
and those
explained
tidal
it.
effects.
It'd be pulled in all
Tidal effects.
directions. You explained it.
Tidal.
You'd be pulled in all directions.
Yeah, I
Not
know, but it's just
not
not. It's not
negate. It
something.
wouldn't negate.
Yeah, because of that they negate. You'll
It
be
wouldn't
pulled in all
negate.
directions. It will not pull you apart. You won't experience that. You'll be weightless.
Well, I think you explained something about the gravity doesn't actually pull you down. It pushes it. The table's pushing me up, and the floor's pushing me up, so I wouldn't feel it if I'm in the center. So
No,
I
no,
can't.
no,
I
no.
kind of get that, but I'm just not buying
No,
it. So
that's not what I said though. Gravity is pulling down. So there's two forces at the same time. There's the weight that's acting downward against the ground, and there's a normal force acting up against you. The thing you experience is the normal force acting up against you. You're not going to feel the weight. You don't feel that. You feel the normal force acting up against you. That's why your feet hurt and your butt hurts and your back hurt, whatever. It's just because the force is acting up against you. But your weight, uh, it's the thing that
the
makes an
same
impression
thing. If
on
you
your
say
bed.
your feet are pushing down, it's the same thing.
But your feet pushing down doesn't make an impression on your feet. It makes an impression on the ground. The ground pushing up makes an impression on your
And
feet.
that's what would happen if there is like sand or clay. You'd make an impression on the ground. So what's the difference?
A difference. It's just two forces acting in opposite directions.
I kind of get the dairy, but if you lose gravity, this whole conversation goes out the window. And I don't want you to assume gravity because I don't think it's actually
You don't have
happening.
to
But
assume anything. I can
that's
feel
why
myself acting against the ground. I can feel the ground
that's why
acting
I
against
objected
me.
to the water being heavier as you go down because I don't think there's gravity doing that. I think that's just density.
How would density do that? The water doesn't get less. Let's say you're in a lake. Let's say in a perfectly um, clean pool, no salts, no anything, just water. There's no difference in densities as you get lower in the pool. There's differences in pressure, but the density of the water remains the same, and you feel the difference in pressure, and it's not because of the density. So
If I put a water balloon on your head, it's going to push down on your head.
yes, that's true.
So you multiply that times 1,000 if you're in the bottom of a lake.
That's
I don't
right.
see a problem.
That's the weight of the water acting on on you in the one water that causes the pressure.
Weight of the water.
The density is consistent in that case. There's no difference in densities. The density is the same. The density of the water at the bottom of the pool and the density of the water at the top.
No, no, no. The more stuff's on top of you, the more you press downward.
Sure, the
If I put a
density.
blanket, if I put a blanket on top of you, you don't feel it. I put like 10 blankets on top of you, feel it. You'll feel that.
Yeah, that's pressure.
You get
That's weight.
dogpiled by a football team. That's like 10 people on you. That's a lot of weight on top of you.
That's a perfect example. You get dogpiled by a football team. They're all the same person. There's no difference between eight. There's a fucking octuplets, whatever. 8 people. They weigh the same. They're all perfectly the same. They pile on top of you. There's no difference in density at the bottom or the top. They're the same people. The person at the bottom, the person at the top have the same density. There's no difference in the volume over the mass or the mass over the volume.
No,
Okay,
no,
but
no, no. There's
there
more
is a difference
volume.
in
No, no,
weight.
no. Kosho. There's more volume happening.
Yeah.
That's why you're getting pressed more.
Yes, there's more volume, then there's more mass. The mass and the volume are
So, well,
equivalent.
hang on. So, if you have a dense object, which I claim is going to fall through a lesser dense medium, in this case, you're on the ground. Football player one is going to fall on you. That he's more dense than the air. He goes down. There's less dense. He goes down through the air on top of you. Now that's one football player on you. Number two football player on you also falls through the air on top of you. Now you have double the volume. That's double the weight on you. You
Yeah.
don't need gravity for that.
So what's double the mass divided by double the volume? That equals mass divided by volume. The density is
You can
exactly
do
the same.
you can do the math for me, Kosho, but that
The
doesn't prove
density
gravity.
is exactly the same. I know that doesn't prove gravity. It proves that the density doesn't change. When you go down in the water, when you
You're
have people
using the
on top
term
of you,
wrong.
the density
You're
doesn't change.
using the term wrong. Density will determine where stuff's going to go. Okay, light stuff on top, heavy stuff on the bottom. This is a natural order of things. Football players go down to the air, and if you're on the bottom, you'll get hit. You're going to get dogpiled. The more football players, yes, the same density, but the more football players, the more volume, the more pressing down. Because why? Because the air is less dense than these football players. Football players go more dense, go through the air downward, and then the
Is
air
it
goes up
obvious that it's not
above
the
the football
density?
players.
It's simply the mass. The amount of mass acting downward on you is increasing. You have double the mass, 3 times the mass, 4 times the mass. 4 people are dogpiled on you. 5 times the mass acting on you. That's 5 times the force. And if it's acting on a single point or some surface area, that's 5 times the pressure. So it has nothing to do with density and everything to do with the uh, the mass, the amount of mass acting
I'm
on.
claiming density, and you're claiming just gravity.
I mean, it's the weight.
It's just two ways to explain it, but
No,
that
it's two different things.
the difference is that you're claiming that mass attracts mass, and I'm saying you don't need that.
I didn't say anything like that. I just said that the weight is what causes pressure and what causes this thing. The difference between weight and density is mass divided by volume, which doesn't really make sense that causes anything just because you increase the amount of mass um,
It
and
does
the volume at the
if
same time.
you want to establish that light stuff goes up and heavy stuff goes down
Sure, but how do you explain how two things are going to be uh, more pressure on top of you than one thing? That's
because
two
it's
things.
double volume. Because it's double the volume going down. In this case, the football players, double, triple volume going down, and that's going to
But
cause more weight.
if you just add volume, all you're doing is decreasing the density.
No,
Yes. If you're only adding volume, you're decreasing the density. If you're adding the volume and you're adding mass,
same way with
you're not
helium balloons.
changing the density.
Take two helium balloons. You might be able to lift up like a toy soldier, right? Take 3 helium balloons. Eventually, you'll be able to lift up your iPhone. You go right up there in the air. Enough helium balloons. More volume
Hmm.
goes up.
It's buoyancy.
Yeah, you can say points. You can say sciencey words.
I'm not saying science. Don't be an asshole, Godric. I know you know this shit, dude. You're actually smarter than a lot of flat earthers. A lot of flat earthers are smart people. Smart people. But I'm just saying, you surprise me sometimes, Godric.
Look. In school, they lied to us. They told us stuff falls down, therefore gravity. This is like third grade. Okay, not before you got into science, right?
Yeah, sure.
Second grade, whatever.
Okay.
What they
Okay.
should have said, they should have said, some stuff falls down, heavy stuff
No, that's not true.
falls down
Listen,
to a medium. Heavy stuff falls down to a medium if it's denser. But guess what?
I mean,
The other part of that is light stuff will go up. If I,
no.
if I,
Let me
if I blow
describe.
my smoke from my cigar, it goes up.
No, it doesn't. Let me describe to you a word
If
before we go.
I let go of a
Hold on,
helium balloon,
Godric.
it goes up. So
God.
the truth is, heavy stuff falls down, light stuff falls up, goes up, and that's
Oh, it's
you
not.
have to tell
Godric.
both sides, not just one
Yeah,
side.
Godric,
So if
Godric,
light
Godric.
stuff's
I
on
get
the
it.
top and heavy stuff's on the bottom, what that is, that's an equal balance. There's no downward bias because
Why do you want to say
light
that?
stuff will be on top, heavy stuff will be bottom. If in that case, you don't need gravity for nothing. It's
You're
just
just
an
repeating
explanation.
yourself, Godric. That's not very polite to do. All right? I got your point at the beginning, man. You think light stuff goes up and heavy stuff goes down. I get it. Okay, I'm going to show you that the word floating, like if something's floating, has a specific meaning. Like astronauts in the ISS aren't floating. Objects in orbit aren't floating. Okay? What floating is when you place something inflatable, like a boat, or not a boat, like a tube or something on top of water, or a basketball on top of a pool, or whatever, or a balloon in the atmosphere. These things that are floating are not being compelled upwards. They're all being compelled downward. The only difference is the basketball in the pool is being compelled downward, and the water is being compelled downward. It has a greater precedence over the basketball because it's more dense. But they're both being compelled downward. And you can easily see this by putting a basketball at the bottom of a bathtub. It's being compelled to the bottom of the bathtub, and you fill the bathtub up with water. The basketball floats on the water. It's still being compelled downward, just above the water. So, in that case, none of that stuff's being compelled upwards. It's just that the basketball has less density than the water, but both objects are being compelled downward. So gravity does compel even the smoke. All these things, they're all being compelled downward. If it's just that the medium itself is being compelled downward at a greater density, I mean, at a greater
So, so you
force.
just got to do something different, Coach. I just want to correct you. When you have a basketball floating in water, that's something different because now that basketball being floating on the water has to do with the amount of water that's displaced. Similarly, you can put a bowl. Hang on, you can put a bowl, which is let's say ceramic, metal bowl, whatever, on water, and because it's displaced in the water, it can float if it's upwards. And if you turn it upside down and you have enough a correct pocket of air, that bowl can also float upside down. So it has to do with the amount of water that's displaced, not gravity.
No, that's exactly right. That's exactly the same thing. If you have a basketball at the bottom of that bathtub, right? The basketball is less dense than the water. So the basketball pushes that amount of water out of the way. That amount of water is now above the basketball. And that amount of water, compared to the basketball, it's the same volume. It has more mass in the water. So that's going to have a more precedence over the basketball, which is what pushes the basketball up because the water is being compelled downward. The basketball doesn't keep going up after it gets to the top of the water. It just it was only ever compelled upwards by the fact that the water was compelled downward. So they're both being compelled downward. Just that like I said, the water has more precedence.
How can you claim the yeah, they're both being pulled downwards because they're both denser than the air, which is my argument to begin with. How light stuff on top, heavy stuff on the bottom. Water, basketballs, bowling balls, on the bottom. air, smoke on the top, helium on the top.
Forget about the air, because the air is just going to confuse things. But the air
Right.
is
Forget about
contained
the other
both.
side because that way we can have gravity.
No, do all these tests in a vacuum. Do these tests in a mercury pool in a vacuum chamber.
Let me
Okay,
claim that
this
vacuums don't
the
happen
same
in
the same
nature,
things the
says
same
Plato.
thing. This does happen in nature.
Nature abhors
Matter of fact,
a
as a
vacuum.
matter of fact, no, all of this stuff is happening in nature. The only difference is that instead of the object, so like instead of basketball, the basketball gets to the top of the water and it floats on the water. They're both being compelled downward. On top of the water is the air. The air comes out of the water because the air is less dense than the water. You get a helium balloon, it rises up above the air because it's lighter than the air, but it's compelled down above the air. That's why there's a float point in helium.
You're
That's why
just
all
saying
helium
that
balloons.
because you're saying that it
No,
propels down. You're just saying that, Coach.
look at Felix Baumgartner. Look at anybody who's ever risen up in a helium balloon. They get to a certain float point because at that point they're floating on top of the air, just like a basketball floats on top of a pool. The same thing.
It's not the it's not the helium that's being pulled down, Kosho.
No,
The
helium's.
It's the latex balloon that's being pulled down.
Oh, so the helium as well. The only difference is because the helium's lighter than the air, the same volume of helium, the same volume of air, the air is heavier, so the air is compelling the balloon upward as it pushes it out of the way until the balloon is now at a point where the helium is actually uh, just as dense as the air around it because there's barely no air up there. At that point, the helium will float, which is like 120,000 feet or whatever.
If the helium didn't have the plastic latex, it would just disperse, Kosho.
Sure, yeah, air will disperse, but
And
that's
according to some globe logic, some helium escapes into space. How does
yeah.
that work? That makes
The
no
50
sense for
per second.
gravity to take.
Why?
Well, doesn't gravity pull stuff down towards the center? So how's helium going into space, Kosho? This makes no sense. Why? Like I just ask questions like like internal
No,
questions, but this shit
Patrick,
doesn't work out, bro.
Patrick, if you
If
surpass the
there's any
escape velocity,
gravity, how in the fuck can helium
okay.
escape into this
I'm
vacuum?
trying to answer. I'm trying to answer that question. I got you, but you might ask it 2 more times, 3 more times. Try to
No, no,
answer.
go ahead. Go ahead.
Yeah, you're right. It pulls everything down um unless it surpasses the escape velocity. So a rocket going faster than the
Oh
escape
my
velocity
god.
will move fast enough that even though it's being pulled back, it's going to escape Earth's gravity. And it just so happens that the only gases that escape Earth's uh, gravity are gases that have enough energy that speed it up faster than the escape velocity at the altitude. And that's
Kosho,
gases that get
I feel
bombarded
like
with the.
you're just parroting Wiki, but that makes no fucking sense, Kosho.
Why doesn't it make
You
sense?
would have a better argument to say that Alpha Centauri has a black hole that's pulling this helium outwards, and that's why it's escaping in space. That would make sense. Or Uranus is pulling it, or Mars, or fucking
Why doesn't the
some other
escape
body.
velocity make sense? If it has the escape velocity, why does it not make sense that it's going to escape? Why does that sound like something that was just made up when it actually has the escape velocity
Well, when you say
and it's
escape
capable of escaping?
velocity, I don't believe in velocity like the way you say it. First of all, how fast is this helium going, Kosho? How fast does it go?
On the surface, the escape velocity is like 25,000 miles per hour. But up at the altitudes that the helium that we're talking about, it's much lower than that. So, I don't know on top of my head, but it's going to be lower than 25,000 miles per hour. And if you have
Kosho, can
gases, if you
anything
have
go?
gases,
Kosho, wait, can anything go 25,000 miles an hour?
yes, plenty of things can go much faster than that.
What?
Yes. The fastest a human has ever gone were the Apollo astronauts as they entered back into Earth's atmosphere. And they were going like 26,000 miles per
Oh
hour.
my god. This is where this is where you're gonna lose me, Kosha, because I don't think that's even conceivably possible.
Then forget about those guys. Just think about the gases.
Back to the helium balloon. We know
Think
helium
about a
balloons don't
gas.
get 25,000 miles an hour. Wait.
Think about no, not the balloon. A gas particle at the top of the atmosphere.
Well,
It gets
hang on.
it gets bombarded with hold on. It gets bombarded with energy from the sun. Cosmic rays, energy from the sun. Those cosmic rays, if they interact with one of those particles at the top of the atmosphere, it's going to give it enough energy, and there's no gases around it, so it's going to be able to fucking zoom off. If it happens to get enough velocity that speed it off to above, the escape velocity, it's not going to be pulled back down by gravity. It's going to be moving too fast to be pulled back down.
Okay, I get this theory, Kosho. If you're on the moon and you're playing golf, you hit that fucking golf ball hard enough, that golf ball can go right to Earth, right? Why? Because you
Sure.
can you can you can escape the gravity of the moon at some point, and then the Earth's gravity will take over, and start pulling to Earth. That makes sense, right? But for helium to escape this gravity field of Earth, that makes no fucking sense. Unless you're going to claim that the
Listen,
moon, unless you're going to claim that the
Patrick,
moon's gravity
if I was with you right
is
now,
going
I'd
to pull it
slap you in the
out,
face. Listen to what you just said. You just said it makes sense with a golf ball, but for some reason it doesn't make sense with a gas particle. What's the difference?
because I didn't explain the magic part. You have to drive that fucking golf ball pretty fucking hard. Matter of fact, I don't think it's impossible for a human to do it. Okay, because
That doesn't matter. It
this
doesn't
hang
whatever
on,
what
because
if you can
this
make it
this
go that
gravity
fast,
field
go
on
that
the moon,
fast.
even though it's 1/6 the Earth's gravity, you still couldn't hit far enough to get it to where you would have to have an escape velocity, not with a fucking 12 iron, right? So you have to shoot that shit with some kind of like fucking artillery missile or some shit.
I
And
don't know
yes,
about that.
it would eventually leave the moon. But a helium gas show is not going to get that escape velocity enough to 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 get to get away from the moon's gravity, much less Earth's gravity. That's my point.
First of all, have you ever heard about the
And no to your 25,000
Patrick,
miles
Patrick?
an hour. That's ridiculous.
Have you ever heard the ionosphere, like the speeds that they talk about? They say the temperatures in the ionosphere. You ever heard this before? They talk about there's like 2,000 degrees in the ionosphere or the thermosphere or something like
Or
that.
like all this like
You ever heard that?
science and stuff show, honestly, like it's all made up.
Yeah,
Nothing,
okay, it doesn't
and
matter.
none of
It
it's
doesn't matter.
provable.
It doesn't matter if it's made up. This is a flat Earth argument that they use. You guys
Okay,
use
so
this.
tell me, I'm gonna listen to you. Tell me the argument.
Yeah, that the ionosphere, there's temperatures that exceed 4,000 degrees. So it's something along those lines. There's temperatures in the ionosphere that exceed 4,000 degrees. This is what people claim. They say that it's impossible for people to go up there because they'll burn up or something. Regardless of that, the point is those temperatures represent the energy that each of these particles have at that altitude, meaning that a average gas particle is has so much energy that this is the temperature that you would this is the average temperature. That's just a description of the average energy of the particles. Okay, so there's so few gases up there, and there's so much energy coming from the sun that all the particles have uh, an immense amount of energy the higher up you go. So it's not crazy. It's not crazy to think that as the cosmic rays hit these extremely fast particles that have no other gases to run into, that it's not difficult for them to exceed the escape velocity. It's just it should make sense, man.
Okay, so now you introduce something different. Now you're saying that not because the helium is shooting up fast into the atmosphere, into space, that's escaping Earth's gravity, but now you're saying the sun's rays are making it happen. You
Yeah, I've
changed the
said it the whole
argument,
time.
Kosho.
I know. I said that.
Congratulations.
I said this the whole time. God, you didn't hear me, but I said it the whole time. I said that that's what gives
To be honest
the
with you, I don't know
particles.
what the hell the sun's rays would do to helium. I don't know what that would
It
do.
gives things energy, dude. Anything it touches, it gives energy to it. So if
I
you
don't.
have,
I don't. I mean,
that's how it
it's
works.
a
How it works, man.
it's a story. I don't know how we can confirm that because we can't go up there and see it
What are
happen.
you talking about? Get a solar panel and get a calculator and see if it works in the dark. And put it in the sun and see if you get fucking energy from it. Turns out you will. The sun does, and the heat energizes things. So if you
I
heat it
imagine
up, it's gonna give it more energy.
helium gas wouldn't move very fast through the air. Any much more than a helium balloon would move, maybe a little bit faster. So
Here,
no, it
try
wouldn't be
this.
enough to
Try this.
escape.
Get a beaker.
Hang on. I'm imagining that I'm just talking out loud that a helium balloon, if that popped, that helium would not be going very fast to space, and when it got there, it wouldn't get very far because it would be stuck at some point, pulled towards the
Yeah, it would
Earth.
float.
Because
Yeah,
that's how we have what atmosphere. This is your model, by the
yeah,
way. And
yeah.
who
But
knows
guess
how
what,
the
dude?
sun would do hitting this
He-
helium? I don't fucking.
Helium
So
doesn't come
kind
back
of a
to the
mute
Earth,
point at
dude.
that point.
Yeah, helium doesn't come back to the Earth. All the helium that we get comes from the inside of the Earth. The helium is one of the rarest gases on the planet because it doesn't come back. Okay,
It just
that's one.
escapes into space. So no gravity,
Yeah,
helium
it
escapes.
doesn't. It doesn't come back down. Anyways, if you get a flask, if you get one of those beakers, you fill it with water. Okay, you put a balloon on the top part of the flask, and you boil the water. The gas will fill the balloon. Okay, it fills the balloon because those gas particles that are heated up have energy. The energy is going to fill the balloon. It creates a pressure inside of the balloon, which fills it up. Okay, so this is what this heat does. Heat will apply energy. This is why heated gas is less dense than cold gas because it has energy that wants it to expand. Okay, so if you
That's
give
why my cigar
gas
smoke
inside
goes
of a
up because
particle,
it's hot.
well, no, not necessarily. It's because it's less dense than the air. And
Oh my, sit down. You ruined it, Kosho.
yeah, but you're right though. You're right though. Heated, yeah, hot air is less dense than cold air, and it will rise up. So I'll give you that.
We know that balloons being heated go up. We know that, but not 25,000 miles an hour. Not escaping this. Not enough to
You're right.
escape this globe
Not
gravity.
a lot of it does. You're right. Not a lot of it does. Only 50 grams of helium per second, and I think 3 kilograms
Kosho,
per
if any of
hydrogen.
it did, it should all go. If 1 gram went, it should all go. This makes
It's
sense,
no,
bro.
dude. No, okay. Imagine. Oh, never mind. Dude, this is getting tedious, dude. If you bombard all the gases with energy, not all the gases are going to go the same speed. Only the gases that are bombarded by this energy in the right direction and aren't and have nothing in the way. Only those gases are going to go have escape velocity, which is why we only lose 30 gram
Okay,
or 3 grams of hydrogen a second and
okay.
50 grams of
So
helium.
only at 12 o'clock noon, when the sun's overhead, did those gases in the area shoot up into space because the sun is empowering those particles, shoot up into
Uh,
space and they escape the Earth's velocity. Is that what you're saying?
no, it's not what I'm saying.
In
The
theory, that can
sun,
happen, but only when the sun is right there above, not on the other
yeah,
side of this globe.
the sun
Not at
lights
night.
half the
It would
earth.
happen at nighttime.
Yeah, it would
Only
not
at twelve
happen at
o'clock
nighttime.
noon will it happen.
Godric, if it's not 12 o'clock noon, is it nighttime? If it's not nighttime, is it 12 o'clock noon? Is that a false dichotomy?
I'm
I think
giving
that is
you
a I think it is a
I'm
false
trying to
dichotomy.
explain your
Half of
model
the
to
earth,
you.
yeah, half of the earth is lit up at once. Not just the places where it's 12 o'clock noon, but the entire half of the earth.
No, Kosho, because it's hottest above your head. It's not hot like at so
Not true.
above your head is what? Is 0 degrees? Is
90 degrees.
how many? What's degrees above your head?
90,
Zero?
90, 90,
90.
90.
Okay, so at 0 degrees would be the horizon.
That's right.
So the sun needs to be 12 o'clock noon, and above your head is you're at 90. At 90 degrees is where the heat is, not at zero, not at 10, not at 20 degrees. At 90
That's right.
degrees, maybe 80, 85. When you start going to 60, 65, then it gets cold, Kosho. It starts getting cold. So
Godric,
you won't have that, you want energy to
Godric.
escape that helium.
The sun has been
It have to
bombarding the
happen.
entire half of the earth with energy, not just the places where it's noon. That's so crazy. Ah, fuck. Hold on, man. I've been sitting here talking to you,
That actually
shooting
doesn't
the
make
shit for so
sense
long.
because if that's the case, why is it hotter at 12 o'clock noon?
It's not hotter at 12 o'clock noon, guys. It's hotter at 4 o'clock in the afternoon. Everyone knows that.
No, that's for a different reason. That's because the air warmed up by that time. The sun's light is hottest at 12 o'clock noon.
You're receiving the most amount of energy per square meter the closer to noon it is. And actually, only the subsolar point is going to receive the most amount of energy per surface, per meter squared or
Okay,
whatever.
so we
That's
agree.
irrelevant. That's irrelevant because the sun is bombarding the entire half of the earth that's lit up Doesn't matter how much light the surface is getting, the entire half of the Earth is being bombarded by the sun's rays. So
Doesn't your Bible claim that there's a sunspot
I
on the
gotta listen.
earth?
I gotta listen for a second, man, because I gotta eat. I'm sweating my ass off.
Okay, we're going to continue. About that sunspot that they claim, that would be the hottest part of the earth, I thought. I mean, because there's a sunspot there, right? Maybe there's not a sunspot. Maybe that's all fake.
What is your profession?
See, old friend, I brought more soldiers than you did.